In this video, I want to give you a very quick introduction to Omnigram Explorer, which is a simple interactive tool for exploring complex computational models. There's a website at tim-taylor.com/omnigram where you can download the program on a number of different platforms and also access user documentation and other useful files. When you start up Omnigram Explorer, it asks you to select a model definition file. If we look at an example of one of these files, this is just a file that you've written yourself which describes the main features of your model. So the tool is used when you have a model that you've run a number of times and recorded data for the variables, input and output variables of that model on a number of different runs. Omnigram Explorer allows you to explore that data. So the model is defined in your XML file, which just lists the different types of variables you've got, whether they're discrete or continuous, their names, range of values, etc. So that's fairly straightforward. So we can select a file like this. Let's choose this one and open it up. And there we go. So what we see here is that each of the variables in your model is given a histogram. Now this is read in, the tool has read in the data from your recorded data file, which was specified in the XML file, and shows you the range of values for each variable observed in your recorded data file. There are three ways of interacting with Omnigram Explorer. The first of which is single node brushing, which you can access by pressing button 1 on the keyboard. In this mode, you can have one variable as your focus node. Let's try this one, for example. If I click on displacement, then this one turns red or the others turn blue. I can then restrict the range of values that I'm interested in for the displacement variable. So this one, we get the values up here to show exactly what values we're looking at. Now, when I do this in the focus node, all the other nodes are changed to show you what distribution you're now looking at in those variables. So for each sample that lies within the selected subset of the focus node, where do those samples lie in the other nodes? Now, one nice thing you can do with this tool is drag this range of selected values from left to right. When you do this in the focus node, you can very easily see the corresponding changes in all the other variables. Now this very quickly allows you to see which other variables are correlated with your focus variable or anti-correlated, and which ones are behaving in the same way as each other. It's very easy to pick that kind of stuff up. Jumping quickly to mode 2, this is multi-node brushing, which is very similar, but in this mode we can select more than one node as focus nodes. The focus nodes are the ones with the red square in the top left corner. Now, again, for the focus nodes, we can select a subset of values. And what happens here, you'll see there are more colors in the other non-focus nodes. What these mean are as follows. So the blue ones, exactly as before, mean that there are samples in this bin, for example, where the values, that sample's value for displacement lies within the selected range, and also that sample's value for model year lies within the selected range. What do the green ones mean? Well, the green areas mean that there's samples here where all but one of the constraints on the focus nodes are satisfied. So for example, it might be that there's a sample here that lies within this region of the displacement variable, but not within this selected region of the model variable. Red means that there are two or more dissatisfied constraints. So in this case, there is a sample here that is not within this range of displacement, and also not within this range of model year. This gives you some idea of sensitivity of the model. So if you see a green area, we know that there is one of these two constraints not satisfied. Therefore, we know that by adjusting one of these constraints on one of the focus nodes, that we could change this green to a blue, for example. Let's try moving the model up. That seems to be going in the wrong way, and so does that. So let's try the displacement. There we go. If we move the displacement and allow a larger range of displacements, then we get more blue in this area. So that's a way of investigating sensitivity of the model to your particular chosen ranges of values for particular variables. The third mode of interaction is a little bit different. This is where you're looking at individual samples. Now, when you first move into this mode by pressing 3 on the keyboard, you will see a number of dots, and you'll see that they are flashing around. What happens here, it's best to do this with just one focus node. So let's look at displacement. You can stop this automatic updating by pressing the right arrow key, which I'll do just now. This has just stopped things in their tracks. Now, what these dots show, these are looking at individual samples, just 5 samples chosen at random from the data file. And it's showing where they lie within the displacement variable in our histogram here. Now, what I can do, in fact, you can change the number of samples you're looking at by pressing the Z or X keys. Let's press X to look at a few more samples. Now, you'll see as I increase the number of samples that each sample in the focus node is colored according to which bin it is in, and we're only looking at samples within the selected range of the focus node. It's only drawing those samples from the data file. So what this allows you to do is to look at where the samples which lie in this left-hand bin, for example, which are colored blue, where do those ones lie in all the other histograms of the other variables. So this gives you an overall picture of the distribution of values, looking at from one variable how those samples are distributed in all the other variables. What else can we do here? We can change, by pressing the S key on the keyboard, you can change the colouring scheme so that they're random colours rather than coloured according to the bin in the focus node. Now, with random colours, this actually works better, random colours, if you have fewer samples. So I'm pressing the Z key here to reduce the number of samples. But let's go right down to, say, 5. Let's even do 3 samples here. So we are looking at 3 different samples, and we can see exactly where each individual sample lies in each of the other variables for this particular case, just by looking at their colour. Now I can press the right arrow key. What that will do is remove one of these samples that we're looking at and add a new one. So there we go, I can keep on doing that and keep on adding new samples. And in fact, I can press the up arrow key, which will then do this updating automatically, and the more I press up, the faster it will go. But this allows you to see individual samples and where they're placed in the histograms of the other variables. So this is another slightly different way of looking at your data. Okay, there are a couple of other things to mention. You can have these arrows here are relationships between variables. Now these are defined in the XML file, so they're things that you have defined yourself. These might have come about through your prior knowledge of the model. So what these are doing is representing causal relationships. So what we're saying here is that the displacement may have some causal relationship to the model year. You might have come up with that yourself, or those causal relationships might have been generated by some kind of causal inference algorithm. So you can put those relationship information in the XML file, and it will display it on the screen here. Now, this doesn't really have any functional significance, but it just shows you what might be interesting relationships to look at. What you can also see here is that I'm able to drag nodes around the screen. Now that can be useful in situations where you've discovered that there are multiple variables which are behaving in a similar fashion. So in that kind of case, it might be useful to group those together so that you're just grouped all the similar behaving variables in one part of the screen. You can also zoom in and zoom out by pressing the plus and minus keys. So that helps when you are looking at larger models. This one is quite a small model, but your own models might have 40 or 50 different variables. You can also minimize nodes by pressing the top right-hand corner, then maximize them again. So all of this means that it's quite easy to arrange the data according to as your understanding of the relationships develops. So you can group things or choose to focus on some nodes and minimize others, depending on what you feel is important. Well, I think that's about it for now. That's enough of the introductory flavor of the model. If you would like to learn more about it, then please do visit the website, download the application, look at the user guide, and I hope you find it useful. Thank you very much for listening.